All right, so this is going to be a video about related rates, and one of the hardest things of related rates problems is knowing when to actually use the related rates way of solving equations. So you have to kind of recognize that it's a related rates type of problem to be able to actually use related rates. I kind of gave it away saying that this is an example of a related rates problem, but I'm going to try to show you why it is based on the problem that's written here. So first thing, it says inside of a funnel of height 10 inches. So we have a picture right here. So we have a picture right here of the funnel of 10 inches, has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by this equation right here. I kind of drew it right up here as well. What I wrote in the black right here is basically everything that was given in the problem. I like to do that right away, is just write down any givens. It says the height is from 0 to 10, which is kind of obvious. It says the height of it is 10, so it can't get any bigger than 10, and it's not going to get into the negative heights. So that's kind of obvious. I didn't actually write that down because I didn't think there was a point to it. The units are inches right here, okay, and then it says the funnel contains liquid that is drained from the bottom. So you can kind of imagine liquid draining out of this thing toward the bottom here. At the instant when the height of the liquid is 3 inches, okay, so I wrote that right here. The radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second, so I wrote that right here. This dr over dt. It is important to note that it says the radius is decreasing at a rate. So when it's a rate, you have to make sure you write dr over dt like I did right there. Also, it says it's decreasing, so then I had that little negative right here as well, so it's negative 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So then I wrote that right here, what we're looking for, and I used a little question mark. So step one is, first you have to understand that it is a related rates problem, and one way of telling that is, one, it asks you in the question, what is the rate of change of the height? So it asks you this right here. It's also telling you a certain rate. In this case, it's decreasing at a rate of 1/5 inches per second. So if you have multiple rates and you're trying to figure out what one rate is based on another rate, that's what the related rates equation is all based on. So it's kind of a light bulb should go off in your head and think, okay, when you see that there's multiple rates here and you're looking for a rate, it's probably a related rates problem. Then what you do after that is you write down all the givens like what I did here basically in the black. And from here, I'm going to try to dissect to figure out what I'm looking for. And again, I wrote down what I'm looking for right here with a question mark. We're looking for dH over dt. Now, since it's a related rates problem, we need a related equation before we can find a related rates equation. So basically, we need to relate the variables that we're using here. In this case, we need to relate R and H. If you notice, we have dr and dH over here. So we need an equation that relates R and H. Well, that's this first one right here because we have R and H in the same problem. So what I'm going to do with this first equation right here is I'm going to do the derivative of it, of both sides, with respect to t. So on the left, you're going to get dr over dt is equal to, okay, the 1/20th is a constant multiple, so I'm just going to write 1/20th again. And then we're going to do the derivative of 3 plus h squared, which ends up just being 2h dh over dt. Now, if you remember, when you do the derivative with respect to time, since the variables don't actually match, the r does not match the t, you have to have that dr over dt like we do on the left, and then that h, when we do the derivative of the h, it doesn't match the t, so you have to have that dh over dt. Okay, so from here, everything that's written in the black is basically the givens, and we can use this to fill in this related rates equation. So that's basically the next step if you want to think of it that way. The dr over dt, again, is right here. So it's negative 1/5, so I'm going to write negative 1/5 in there, is equal to, first before I go on to the next part, I'm going to simplify this really quick to be 1/10. H is 3, so this h right here, I'm going to just put 3 over 10, because the h is 3, and then it's divided by this 10 right here, times dH over dt. Now, if you notice, that's what we're looking for. If you remember right here, it says we're looking for dH over dt. Well, that's the only variable that's left in this problem, in this blue line right here. So basically, I'm just going to solve this. I'm going to multiply both sides by 10. So that's going to cancel. This whole thing's going to cancel. You're going to left up with negative 2 on this side. And then we're going to divide both sides by 3. And you're going to end up with negative 2 over 3. In this case, it's going to be inches per second because height's in inches and the t is in seconds, is equal to dH over dt. And basically this is what we're looking for. So I'm going to highlight it really quick. So this is basically how to solve a related rates equation. Now this problem is very involved. It's really easy to get intimidated by it, but if you just kind of break it down, write down what's given, try to find that related equation, do the implicit differentiation with respect to time, the problem does get a little bit easier. So if you have any questions about anything in this video, let me know.